Braid, scalable touch-sensitive lighted cords, using spiraling, repeating, sensing textiles and fiber optics. The Braid interactive textile uses braided conductive yarns to sense proximity, touch, and twist, and embeds fiber optics for visual feedback. Braid leverages repeating sensing and light matrices to enable new interaction techniques, form factors, and capabilities for everyday objects and devices. Braid enables interaction techniques based on the capacitive sensing of proximity, contact area, contact time, roll, and pressure. This visualization illustrates Braid's sensor response from different interactions with the textile. The capacitive sensing gives us the ability to sense hover and contact, including contact area. Contact area enables distinguishing between a finger or a hand that is grabbing the braid. We use this feature to also distinguish between different pinches and grabs, for example. When braid is grabbed, we can also continuously sense changing pressure during a gesture. We enable continuous manipulation by detecting a rolling motion of the braid between the fingers, which can be described as a twisting gesture. Through our sensing topology, this twisting maps to a relative motion across a touch matrix, which enables the tracking of precise rolling gestures for clockwise and counterclockwise motion with varying speed. Similar to traditional touchscreen interactions, we can map varying contact times to specific actions. This capability enables short presses, long presses, or press and hold as mechanisms to trigger different discrete actions. Braid is based on a helical sensing matrix, which uses 8 conductive threads spiraled around the core. In the left braid, conductive yarns are shown in color, while passive support yarns are shown in gray. For the capacitive sensing matrix, the yarns in the Z direction are used as receive electrodes, and the yarns in the S direction are used as transmit electrodes. The center shows a flattened helical sensing matrix that illustrates the resulting infinite number of 4x4 matrices which repeat along the length of the cord. The right braid shows how we can replace passive yarns with fiber optic lines to embed visual feedback using the same topology. Here we have added 4 fiber optic lines F0 through F3 highlighted in yellow. Rotation gestures are detected by tracking horizontal finger motion across the red, yellow, green, and blue columns. When the user manipulates the cord, the capacitive coupling between the threads running in the S and Z directions is modulated by the user's fingers and can thus be used to determine the type of interaction that occurred across the matrix. Interactions can be sensed anywhere on the cord since the braided pattern repeats along the cord's full length.